Okay, so what we're working with today is section 4.6. It's called the Fundamental Theorem of Algebra. I don't really teach the theorem as much as just understanding the processes that are in this section. So the first thing, and we've gotten into some more graphing, so hopefully you can remember some of the things about graphing. Remember, if it's x squared, it goes two directions, right? X cubed has three directions, so down, up, down, up. X to the fourth has four, so down, up, right? Remember, the degree tells you how many directions. Well, the degree also does another thing. The degree will also tell you how many zeros there's supposed to be, okay? So the degree is the number of solutions there's supposed to be. And remember, we find the degree by finding the biggest exponent. So right here, this is my degree. So this should have 4 solutions. Okay. My degree for this one, it's not in order. It's the biggest one is 5 right there. So this one should have 5 solutions. Okay. So the type of solutions kind of depends on what happens. And so the way we find this is when a graph intersects the x-axis, which that's when y is 0, it is a real solution. If you don't have enough real solutions, then that means there has to be some imaginary solutions. And when you have imaginary solutions, they come as pairs. And if you remember why, because the way I got imaginary is if I had something like x squared is equal to -4, remember when I take the square root of those, I get plus or minus 2i. The only way you can get imaginary is if you're taking the square root, which means there's a plus or minus. Okay, so an example would be, let's look at this graph here. Let's say a graph does this, right? I know that this is an x to the third, but I only see one real solution. So that means I have one real, but I'm supposed to have 3 solutions, right? So since I have only one place where it crosses the x-axis, that means that I'm going to have 2 imaginary. Okay? All right, so let's go down and look at some examples. You're going to have to write these down on your notes. Oops, don't want to do that. Come on, mouse. That didn't get dragged bigger. Let's drag that bigger for next time. Okay, so find all zeros. So the way we're going to do this is we're going to plug in with desmos, and we're going to see what we have. And then we're going to go back and learn what to do next, but we're going to start with this, okay? So go ahead and plug those in desmos and see what you find. Okay, so when we look at number 3, I should notice that there should be 4 zeros, right? Okay, so let's look at the graph. Okay, so here's the graph. I do have 1 0 right there at -1.325. So let's write that down. X equals -1.325. But then when I go back here, look, I have this one at 0. Oh, what's that? At 0. So now it does a funny curve through 0. Remember when it's x squared will bounce off of it. This is kind of doing a x cubed through it. So remember, that's multiplicity of 3. So I have -1.325 as one answer, but then I have 0 3 times. So that adds up to 4. So those I have, my answers are right there. Okay, so let's look at number 2. For number 2, same thing. I should have 4 answers. So let's go back to Desmos and see. I'm going to turn that graph off. Why does it keep doing that? Turn that one off and this one on. Okay, so I have, what is that, -1, 0, and 2. So let's write those out. Oops, hold on. -1, what was it? 0 and 2. Okay, well, let's look at this. I'm supposed to have 4. I have 3 here. So now let's see. Oh, it curves at the 0, 0. So that means, remember, it hits it and bounces off of it. So that means the 0 has multiplicity 2. Well, I have -1, I have 0, I have 0 again, and then I have 2. So that has 4 answers. So that's it. Okay, let's look at number 3. Okay, turn off graph 2 and go to number 3. Oh, look at that. I can only see 1, but I'm supposed to have 3. The only answer I have is at -3. So I have x is -3, but again, I'm supposed to have 3. I only see 1 real answer. Let's go here, go away, and let's kind of zoom out and see if we can find more. Oh, do you see how it curves up here? So that means there's going to be 2 imaginary, okay? So I have 1 real, and I'm going to have 2 imaginary. We're going to have to figure out how we're going to find those, and we're going to do that in our next set of problems. Okay, so let's leave it right there for right now, and then let's go back up and look at these examples. Okay, so determine the number of imaginary solutions. I should have probably done this problem first, but I got ahead of myself. Okay, so you see how this has 4? So I'm supposed to have 4 answers. This one, I could see this one right here. X is -1. And I can see this one right here, x is 3. So that tells me I'm supposed to have 4 answers. I see 2 real answers, and that means I'm going to have 2 imaginary answers. So we need to find them. So when you're finding them, I know that -1 is an answer, and I know that 3 is an answer. And so what we do is we get rid of those answers by doing synthetic division. So I'm going to do -1 in my box. And then remember, for synthetic division, you have to make sure that your exponents go down. So I have a 4, 3, 2, a 1, and then none. So then I'm going to write my coefficients. Okay, so remember, synthetic division, you add going down, so that's 1, and then I multiply by what's in the box. Add going down, multiply by what's in the box. Add going down, multiply by what's in the box. Add going down, multiply by what's in the box. Now if you notice, you get 0. And really you should get 0 because I know that -1's an answer, so I should have no remainder. So I've taken care of this. Now I'm going to go to the next one. So I put the 3 here, and I just use these numbers now. Add going down, multiply by what's in the box. Add going down, multiply by what's in the box. Add going down, multiply by what's in the box. Okay, so now since I started with x to the 4th, this one would be x to the 3rd, but then I got rid of another one, so this is x squared. So it's x squared x. And so this is what I have. I have x squared plus 5 equals 0. Now, if I could factor this, I would have found real factors like I did up here, real zeros. But I can't factor this, so now I have to solve it. So I subtract 5 on both sides, and so I get x squared is equal to -5. And to get rid of a square, I take the square root. And so remember, when I take the square root, I get a plus or minus. That's how I get 2 answers, because there's a positive answer and a negative answer. And then the square root of 5 is square root of 5. But you see this negative, I can take that out. So then my 2 real answers are -1 and 3. And my 2 imaginary answers are plus or minus I square root of 5. And that's the answer for that problem. So again, what I did was I found my real answers where it crossed the x-axis. I knew I was supposed to have 4, but I only had 2. So I had to divide by those two so that I could get something to solve to find my last one. Okay, so let's go back and finish that problem that we started. This one right here, number 3. Remember, we only had the one real answer at -3, so we have to go find our two imaginary answers. And so I'm going to take -3, put it in my box. Let's make sure our exponents go down. 3, 2, 1, none. So then I write my coefficients and do synthetic division. Okay, I would like you guys to do that step, and when you think you have it, press play so you can check your work. Okay, so when you do this, you should have ended up with 3x squared plus 4 equals 0, and you know you got it right if you got a 0 here. Okay, so I know that it doesn't go into it evenly. I can't factor that, because if I could factor it, I would have real zeros. So I have to subtract 4 on both sides, and then I have to divide by 3. Okay, so remember, kind of running out of space. We'll have to figure this out. So remember to get rid of a square. I take the square root, and so I get x is equal to plus or minus the square root of 4 over square root of 3. It should be a -4. Okay, so now the square root of -4 is plus or minus 2i, but I'm going to be a stickler. I'm not going to let you keep that square root of 3 on the bottom. So remember, we practiced this. You put a square root of 3 on the top and the bottom. And so now I have plus or minus 2i square root of 3 over 3. So my answer is -3 and then plus or minus 2i square root of 3 over 3. And those are my 3 answers. Okay. This part's a little harder with the radical, but you've done this before. You will not have a ton of them that are like this, because a lot of them you'll find all the real zeros. But when you don't find all the real zeros, you have to go back and find the others. Okay, so let's go and finish the top part of our notes now. Now what happens is sometimes I'm going to give you the answers and you have to write the problem. So on the last one, I wrote the problem and you had to find the answers. Now we're going to go backwards. Okay, I'm going to use this colorful pen today. This one's fun. Okay, plug the zeros into parentheses. This is cool. Watch, it changes colors. Remember that that they are the opposite. If you have an imaginary, then you have to have a positive imaginary and a negative imaginary. And once you find your factors, you multiply them and combine like terms. Ooh, isn't that cool? Okay, so here's an example. So I have a positive 2, so that means it makes -2 in parentheses. I have a -3, so that means it makes a +3. And I have a positive 1, which that means it makes a -1. What I'm going to do is I'm just going to focus on 2 first. I'm just going to do this. And what I do is I multiply those together. So I get x squared, and you could use the box method, or you could use FOIL or distributive property. It's up to you. So x squared plus 3x minus 2x minus 6. And then I combine my terms, and I get x squared minus 2x. I'm sorry, not minus 2x. Plus 1x minus 6. Now what I need to do is I need to bring this thing down, and I need to multiply. And again, you could use the box method, or you could use the distributive property method. FOIL doesn't work here. That's why I don't really like to say FOIL or use FOIL. So I'm going to rewrite it because I like to have my 2 terms first. I don't know why, it's just the way I was always taught. So x times x squared is x to the 3rd plus x squared minus 6x. And then I do the next line, and remember I move over 1. And then now I just combine them. And so I get x cubed, these are gone, minus 7x plus 6. Oops. And so that's the function. Y is equal to that. If I plug that in the calculator, I would get those 3 zeros. Oops. Okay, so again, you plug them in the parentheses, and remember to do the opposite, and then you just have to multiply them all together. You cannot multiply 3 at the same time. You have to do 2 together, find that answer, and then multiply it by the last one. Okay, now let's go to our last set of examples. Okay, I would like you to try number 4, and when you think you have it, press play so you can check your work. Okay, so it doesn't matter the order that you multiply, but if you did these first two here, you would have gotten x squared minus 3x minus 10, and then bring down the x minus 3. Last problem I did, I showed the arrows method with distributing. This time I want to show the box method, remember? So you set it up, and so it's x cubed, negative 3x squared, negative 10x, negative 3x squared, positive 9x, all right? And then positive 30. Your diagonals go together. So I end up with x cubed minus 6x squared minus an x plus 30. And so y equals that, and that's the answer. Okay? All right, this one, when you have multiplicity of 2, so a 0 just means it's an x, nothing in parentheses, and then multiplicity of 2 means you have it twice. Okay, so multiply that out and see what you get, and then press play. Okay, if you did these two first, you get x squared plus 1x. And then I distribute again, and I get x to the third plus x squared plus x squared plus 1x, and these two to go together. And that's the answer. So lots of multiplying here. You just have to multiply, find that answer, multiply again. Okay, so let's look at what happens here. This one's a little bit of a trickier one. So I know I'm going to have x minus 3 and x minus 5. This is the part that we're going to leave off for a second. That's the tricky one, okay? So let's go ahead and just find this answer here, and then hit play when you have it. So you should have x squared minus 8x plus 15. Okay, so we're going to come over here and talk about this. So if I have a plus or minus, if I have a 5i, I really have a plus or minus 5i. Okay, so we're going to kind of work backwards thinking about how I get this. I think it's easier to work backwards than doing the substitution process. Okay, so the only way I'm going to get a plus or minus is if I have a squared. The only way I get an I is if there was a negative number, and I took the square root of something and got 5. Well, I took the square root of 25 to get 5, and so this is a negative 25. Now what I want to do is I need to move this to the other side. And that's the problem that would have given me a plus or minus 5i. So I'm doing the opposite. So I squared the left. All right, so that means I have to square this side. And 5 squared is 25. And this is the only place where you can't really, if you square an I though, actually I squared is negative 1. So you know it's a negative. Okay, so then now I'm going to bring that over, and I'm going to multiply it by that. So see if you can multiply those. I would recommend maybe the box method, because it does make it easier when you do a binomial times a trinomial. And then let's check your answer. Okay, whether you did the box method or you did the arrows and distributing, you should get these numbers. Okay, now usually for box method, diagonals will add up, but if you notice, that's not going to work here. Let's see. I have a 15x squared. That goes with this one. Those are the only like terms. So my answer is x to the 4th minus x to the 3rd plus 40x squared minus 200x plus 375. Okay? So the hard one on this one was figuring out how to find the factor from a 5i. But if you kind of follow this process, it'll work. Okay, that's it.